process it all the time. Okay?
Depends on time, right? It's just a factorial.
Yeah, because if you guys look at the next term, A4, wouldn't that be 4
Times 6 times 1.
times 3 times 2 times 1 times 1? Which would be equal to 24. And guys, what a lot of you have already noticed is that, okay, well the next one's going to be 5 times 4 times 3 times 2 times 1 times 1. That's the definition of factorial, isn't it, guys? If you don't believe me, just keep doing it. Okay, a sub 5 would be equal to 5. Now I'm running out of, I guess, differentiating squigglies, so what I'm going to do is I'm going to start with the parenthesis again. 2 times 1 times 1. Which is equal to 120. Now, if you guys, let's say for some reason you guys just had 1, 1, 2, 6, 24, and 120, okay? How many of you guys would have recognized that that's the pattern of factorials? Maybe a few of you guys, right? So some of you guys know like the next one's going to be what, 720, and then 50, 40, and then after that. But I bet you not a lot of you guys know like your factorials up till 10, okay? But I bet you everybody can clearly see that this is just going to be a factorial, right? So if I was to guess a closed form for this, which let's call that a sub n, that would just be n factorial. Okay? And that's much easier to work with. Okay? So what we did, guys, was we took something that was recursive, this a sub k times a sub k minus 1. And then all we did was we just used the method of iteration. And you guys see what the method of iteration is? You're just plugging previous instances back in. And we're not computing, we're just keeping it into the elongated form, okay? A lot of times that'll work out nicely. Sometimes it's just easier to compute. Okay? Questions I can answer, guys? Okay, so let's take a look at the next example. Okay? Again, we're going to use method of iteration, not too difficult. So we have that b sub k is equal to b sub k minus 1 divided by 1 plus b sub k minus 1. Okay. And then we have that b sub 0 is equal to 1, our initial value. All right. Now this one looks like it's really ugly. Believe it or not, guys, this one's a little bit easier than the previous because everybody's going to be able to see what happens this time. Okay. So we know b sub 0 is 1, right, guys? Everybody knows this. So b sub 0 is 1. What would b sub 1 be equal to, guys? 1 over 2, or 1 over 1 plus 1, right, guys? So I like both of the answers. 1 over 1 plus 1, or in other words, 1 half. Okay? So that's not so bad. b sub 2. There's 2 ways we can write b sub 2, right, guys? Let's say for some reason I use the previous iteration. Okay? What would b sub 2 look like using the previous iteration?
Half divided.
Well, 1 over 1 plus 1, right? 1 plus 1 over 1 plus 1, right? That's how a computer does it. A computer doesn't have to think about it. It just does it. Okay? Now, Art, what you were saying is 1 half over 3 halves, right?
Yeah.
That's the way we compute it. Okay? So this would end up being 1 half over 3 halves by computation. And guys, what do we know about 1 half over 3 halves? 1/3, right? The 2's would cancel out because they're both in denominators. So this is just 1/3. Okay, that's not so bad.
Oh, so this whole thing adds up to 2, right? Like if you add the 2 into infinite series or something like that? This is the part of the Ramanujan series, right?
No, it doesn't add up to 2,
Or
but it will converge to a value.
1, right? Or something.
Not 1. Okay? It will converge to a value. We just don't know what the value is yet.
Okay.
Okay? We can find it. Okay? All right. So, b sub 3. All right. Now this one you're not going to like too much. That's okay. This would be equal to 1 over 1 plus 1 divided by 1 plus 1 over 1 plus 1 divided by 1 plus 1 over 1 plus 1 divided by 1 plus 1 over 1 plus 1. Okay? That's how a computer would remember b sub 3. Okay? Computer's not going to go through and it's not going to say that it's 1/3. It's just going to use the previous instance. Okay? Now, of course, guys, we can go through and do this very easily, right? Because we already know that it's 1/3 from the previous. So we know that the numerator is 1/3. The denominator is just going to be 1 plus 1/3. Or in other words, guys, what's the denominator?
4/3.
4/3, right? And if we were to simplify that, guys, what does that work out to be? 1/4. Now we're seeing a pattern, aren't we, guys? I bet you guys can guess the next term and the next term and the next term, right?
1/8, 1/8,
No, not 1/8.
1/10.
1/5, right? Because notice what's happening, the denominators are increasing by 1 each time, right?
Okay.
It's not a geometric, it's an arithmetic type of series, okay? So, let's say for some reason I was to ask you guys for some sort of closed form for this. Okay, so, let's say and I wanted to know what b sub n was equal to. Okay, anybody have a guess as to what b sub n is, John?
1 over n plus 1.
1 over n plus 1, okay? John, provided that n starts at what number?
Let's start at 0.
Yes, sir. Excellent. Because if you plug 0 in, then you get 1, which is the first number.
But if you start at -1.
If you start at, let's say you shifted the index, then you would just say -1 plus 2 would get you to that, okay? So you could shift the index, huh?
So it says there we're starting k is greater than or equal to 1. Why is it not 0? Because 0
Ah.
would also give you the first.
Right, for this one. Well, what we're doing is we're saying that we already know the first term. So we don't need to necessarily know what b sub 0 is, so that's why we started 0.
Oh,
It has to be given to you, okay? So in this case, what we're going to say is that n is an integer, n bigger than or equal to 0, okay? We probably should have done that for the previous problem. Let's go ahead and do that. We should probably give ourselves some initial values. To make the previous problem work, what should the domain be for this guy? Well, obviously the domain's integers. Yeah, we should start at 0, shouldn't we, guys? Because let's think about plugging 0 factorial in. 0 factorial gives you 1. 1 factorial gives you 1. 2 factorial gives you 2. So we would just say n bigger than or equal to 0. Okay? In fact, let's make that part of the solution. Because for sequence, we really should have some domain and we should have some initial value. If we don't have those, then unfortunately this problem doesn't go anywhere. Okay. Questions I can answer about that, guys? Okay. So let's do one more of these, and then we'll be done for today. So I have c sub k equals c sub k minus 1 plus k squared. And we're saying that case, it should be c.
Yeah,
I'm
so
sorry,
it'll be a c sub
this
1.
should be c sub 1 equals 1. So typo. So let me scratch that out so we don't do that. I guess we're not doing anything. It's not going to like any of that. Oh, there we go. So that's c sub 1 equals 1. Okay. So, c sub 1 is going to be equal to 1. So, we already know what c sub 1 is, right, guys? C sub 1 is equal to 1. C sub 2. If I was to ask you what c sub 2 is, what would you guys tell me?
1 plus 1 square.
1 plus
Sorry, 2
2
square.
squared. Good. Okay. Which is 5.
5.
I mean, that's nice. What about c sub 3?
5 plus 3 square.
Okay,
1
5 plus 3 squared, or
1 plus 2 squared plus
3 squared. Okay? Or 5 plus 9, which is 14. Okay. So, does that make sense, guys, so far? All right. C sub 4.
So 1 plus 2 square plus 3 square plus 4 square.
So 1 plus 2 square plus 3 square plus 4 square. Okay. So guys, does everybody see that all we're doing is we're taking the previous iteration, that's going to be the c sub k minus 1, and then we're just adding the next square, okay? That's going to work out to be 30, although that really doesn't help us too much. But I bet you guys can figure out the pattern for C5, C6, C7, right? Like for instance, if I asked you what C5 was, C5 is what?
1 plus 2
And then C sub 6 would be equal to 1 plus 2 square plus 3 square plus 4 square plus 5 square plus 6 square, right guys? So in other words, guys, doesn't this recursive iteration sequence just keep adding the next perfect square each time? Okay? So, if I was to guess a closed form for C sub n, okay, what I might guess is I might guess something like n, 2n plus 1, n plus 1 divided by 6, right guys? What? You guys knew this. We proved this already. Exam 2. We can prove this by using mathematical induction, right? Very easy, right? Didn't we take part of the course? In fact, we took a month of our lives to say that if I was to keep adding the nth term, then I would get something that looks like this, okay? Now the question is, well, how do you know that, right? Well, we proved it by induction. If only there was a list of nice closed form summations that you have. Oh, what a coincidence. I have a list of nice closed form summations that we should know, okay? And a lot of these we did prove already, okay? So let me give these out to you guys. Okay. Yeah, and you guys probably wouldn't know that off the top of your heads, okay? I only know it because I have nothing better to do with my life than memorize closed forms of special summations. Yeah, that's it.
You realize you don't believe me, right?
Yeah, big bucks money, yes.
We don't believe you, we already know on your free time you just playing.
Oh, yeah. Free time. I'll wait till everybody gets a copy of this, by the way, so, because I want to make sure you guys understand how this works. Okay.
Thank you.
Thanks, Martha. Thanks, Martha. Okay. Guys, take a look at maybe the third or fourth one down. Okay. I want you to notice that 1 square plus 2 square plus 3 square plus 4 square up to n square is equal to n plus 1, 2n plus 1 over 6. I just wrote the formula differently. It's the same thing, right guys? So, now, we could prove this by induction, but we've already proved it. In fact, couldn't we prove any of these by mathematical induction? In fact, a lot of them you did, okay? Like for instance, the first one we did for an assignment, the second one we did for an assignment, this guy was on the exam review, this I think was the actual exam question, or actually no, I think the fourth one was the exam question, or fifth one. This one I'm not touching, the end of the fourth. But a lot of these guys are ones that we either did for homework, or we did in class, or we did it on a review or something like that. So you guys have proven these, okay? It's just up to us to recognize these, okay? And that's where this becomes difficult, because if you didn't recognize that this is from the special forms of the summation sheet, okay, so let's write that. So that's from the special forms of summation sheet, okay? Which you guys are welcome to use for the final, provided that you guys don't write anything on it, okay? It might be very difficult to take this recursive relationship and write it into this relationship, okay? So does that make sense, guys, as to maybe why? Like, remember early in the course, it's like, well, when would I ever use mathematical induction? Well, this is an application of mathematical induction, where we can take these recursive sequences and write them into closed form, proving these formulas. Okay, so it's kind of neat how stuff builds upon itself in this course. Okay. Questions I can answer about this, guys? All right. Now, it doesn't always work out this cleanly. Okay, sometimes we have to do some algebra at the end to manipulate. Okay, that's what we're going to take a look at when we come back after break. Okay. All right. So we'll stop here for today. All right. Yes, sir.
Where does n start in this?
Oh, that's an excellent question, because if that doesn't work, then we're done with this, okay? So we need the first term to end up being a 1. So I would suspect that n should start at 1 for this. Okay, so we're going to say n is an integer. Thanks, John. N bigger than or equal to 1. Okay. And by the way, guys, if you don't believe me, just go through and just start trying to figure out for like maybe plug a 3 or a 4 or a 5 or something like that in, and you'll see it works out nicely. Okay. All right. Any other questions, guys, I can answer? Okay. So I do have your guys' assignments, and I do have the exams graded. I posted the exam grades on Blackboard. I can't give the exams back yet because I had one student that had a documented reason as to why they couldn't take it, aka jury duty. There's nothing you can do about that when the country calls, so I will get back the assignments, obviously. I can't get back the examinations, all right? But you guys know your grades on Blackboard, all right? And if anybody wants to look at it, I don't mind if you guys come up and look. Okay, thank you, sir. All right, so I'll give you guys back your assignments, and then if you guys don't have any questions for me, then you guys can leave after you get your assignment.